Hello and welcome. In this chapter, we're diving into the world of requirements engineering. You can think of it as the essential blueprint for a building. It's that incredibly detailed plan that gets drawn up long before anyone even thinks about pouring the foundation for a software project. This is the absolute bedrock of success, and as we're about to see, getting this blueprint right is, well, it's everything.
So let's just kick things off with a big question. Why do so many software projects fail? Why do they blow past their budgets, miss deadlines, or maybe worst of all, just completely fail to deliver what the user actually wanted in the first place?
And the answer, maybe surprisingly, often has nothing at all to do with the code. The problem usually starts right at the beginning, way before a single line of code is ever typed out. It all begins with the requirements.
Okay, so here's our game plan for this explainer. We're going to start by defining what requirements engineering actually is. Then, we'll dive into the two key types of requirements you'll always have to deal with. After that, we'll walk through the entire process, step by step, from figuring out what users need and writing it down, all the way to that crucial final stage of making sure the requirements are correct and handling the changes that will, trust me, inevitably pop up.
All right, let's jump right into Section 1. What is requirements engineering? Like we said, this is all about defining that blueprint for our software. So let's get a really clear definition of what that actually means.
So what's the textbook definition? Requirements engineering, or RE for short, is the whole process of finding out, analyzing, documenting, and checking two major things. First, the services a system is supposed to provide, and second, the constraints it has to work under. The really critical idea here is that it's about deeply understanding and defining the problem before you ever start trying to build the solution.
Now, this slide highlights a really important distinction. Requirements aren't just one thing. They exist at two different levels of detail, mainly because you're writing them for two completely different audiences. On one side, you have user requirements. These are the high-level, big-picture statements, usually written in plain English for clients and managers. They describe what the system should do. Then, on the other side, you have system requirements. These are the nitty-gritty, detailed, technical descriptions of functions and constraints, written specifically for the developers who need to know exactly how to build it.
And this example just lays it out perfectly. Let's take a look at this Ment Care system. The user requirement is simple, right? The system shall generate monthly management reports showing drug costs. Easy enough. But look at how that one single sentence just explodes into multiple, very specific system requirements for the development team. They need to know when to generate it, what time it should be ready, exactly what data to include, and who's even allowed to see it. This translation from a general need into a detailed spec is really the heart and soul of requirements engineering.
Okay, let's switch gears and move to our second section. Now that we've got a handle on what requirements are, we need to break them down into the two main categories they fall into: functional versus non-functional. This is a super fundamental concept, and the easiest way to think about it is just the difference between what a system does versus how well it does it.
So, functional requirements are pretty straightforward. They describe what the system actually does. For instance, a user shall be able to search the appointments lists for all clinics. That's a clear function. Non-functional requirements, though, are about the constraints on those functions. They define how the system is, things like its performance, its reliability, its security. And you can probably see why these are often even more critical. Think about it. A system can have all the right functions in the world, but if it's painfully slow, constantly crashing, and totally insecure, it's basically useless, right? And these non-functional requirements don't just come from nowhere. They generally stem from three main areas. First, you have product requirements, which are all about the software's behavior, things like performance goals or how easy it needs to be to use. Then, you have organizational requirements, which come from the company itself, like policies that say you have to use a specific programming language. And finally, there are external requirements, which are imposed from the outside world, things like legal regulations, safety standards, or ethical guidelines. Now, here's one of the biggest challenges you'll face. Non-functional requirements often start out as these vague, fuzzy goals. A client might say, the system should be easy to use. But what does easy actually mean? As an engineer, you can't build that, and you certainly can't test it. The key is to translate these goals into something verifiable, something you can measure. So, easy to use becomes, medical staff shall be able to use all functions after 2 hours of training. Now that's a specific, testable metric we can work with. Reliable becomes a specific uptime guarantee. This is an absolutely vital skill to develop.
So now that we have a good grasp of the different kinds of requirements, let's move on to Section 3, the requirements engineering process itself. How do we actually go about finding, defining, and checking all of this? Let's take a look at this structured journey of discovery. You know, it's really tempting to think of this as a simple 1, 2, 3 linear process, but that's not how it works in the real world. It's much better to think of it as an iterative spiral. You're constantly cycling through these 3 core activities, getting more detailed with each loop. You start with elicitation, that's the discovery phase. Then you move to specification, that's the documentation. And finally, you have validation, checking that you got it right. Then you spiral back around, using what you learned to refine and add more detail. So let's dig into that first crucial activity on our spiral. Section 4 is all about eliciting user needs. This is the detective work, the discovery phase. So the big question is, how do we actually find out what people really need? There are a lot of techniques, but they often boil down to 2 main approaches. The first is interviewing. You sit down with the stakeholders, the users, and you just ask them questions. This is great for getting a general, big-picture understanding. But the second approach, ethnography, is often way more powerful. This is where you actually go into the user's environment and just watch them work. This is fantastic for discovering what we call implicit requirements, the things people do automatically, the little shortcuts and workarounds they've developed that would never, ever come up in a formal interview. It shows you the messy reality of how work actually gets done.
And this is exactly why techniques like user stories are so effective. Just look at this example for a learning system. Instead of asking some abstract question, we get a concrete story about Jack, a teacher, and a project about the fishing industry. This narrative makes the needs real and tangible. It gives us context, motivation, and reveals specific problems we need to solve, like needing a photo-sharing site where teachers can moderate the content. Stories just make it so much easier for everyone to get on the same page.
Okay, so we've done our discovery, we've interviewed people, we've observed them. Now we have to write it all down. And that brings us to Section 5, documenting the requirements. This is where we take all those informal conversations and turn them into a formal, agreed-upon contract. Now, the most common way to write requirements is just using natural language, plain English. It's expressive, everyone can understand it. But it has a massive problem. It can be incredibly vague and ambiguous. What does fast mean? What exactly does user-friendly look like? To get around this, we use structured specifications to add some much-needed clarity and precision. And here's a perfect example of that. This is a structured specification for a function in an insulin pump. See how it breaks everything down? There's a clear function name, a description, specific inputs and where they come from, outputs and where they go, and a very precise description of the action to be taken. This leaves almost zero room for misunderstanding. It's a crystal clear instruction for the developer. And that brings us to our final section, which covers the last part of our RE spiral, validation, and the ongoing reality of managing change. So we've written our blueprint, but now we have to ask 2 really tough questions. Is it the right blueprint? And what happens when halfway through construction, the client decides they want to add another floor?
Before we even think about building, we have to validate the requirements. This means running them through a series of critical checks. Validity. Does this thing actually solve the user's real problem? Consistency. Do any of our requirements contradict each other? Completeness. Do we miss anything important? Realism. Can we actually build this with the time, tech, and money we have? And finally, verifiability. Can we write a test to prove that we've met this requirement? If the answer to any of these is no, it's time to go back to the drawing board.
And look, change is going to happen. It's inevitable. The business changes, users get new ideas, the requirements will evolve. That's why we need a formal process to manage that change. It's a 3-step process. First, analyze the proposed change. Second, analyze its impact and figure out how much it's going to cost. And only then, after a conscious decision has been made, do you actually implement it. This simple process prevents chaos and makes sure every change is a deliberate, well-understood decision.
So, to wrap this all up, let's just quickly review the big takeaways. First and foremost, requirements are the blueprint for software, and getting them right is absolutely critical for success. Remember to distinguish between the high-level user requirements for the client and the detailed system requirements for your developers. We also learned that the non-functional stuff, how well a system works, is just as important as what it does. The process itself is an iterative spiral of discovery, documentation, and checking. And finally, always plan for change because it is going to happen.
And I'll leave you with the final thought to connect all this to your own life. Think about your absolute favorite app on your phone. What is the one non-functional requirement? whether it's speed, security, how it looks, or just how easy it is to use, that you absolutely could not live without. It really makes you appreciate how much of a system's true value lies way beyond just a simple list of features. Thanks for joining me.